I hope this is good. Hope this is visible now to you guys. We want to talk about SLAAC and the DHCP version 6. We have to talk about SLAAC and DHCP version 6. This is a concept that is borrowing from what we talked about yesterday, and not very far. The concept is still the same, and this time round, DHCPv6 is actually DHCP for IP version 6, and it has a special, feature called SLAAC. Special feature called SLAAC. Now, basically, SLAAC means stateless address auto configuration. Stateless address auto configuration, and it's a concept that we are also going to talk about. So today, the major objective of our study is to configure a dynamic address allocation in IPv6 networks. And so we have, we're going to explain how an IPv6 host can acquire an IPv6 configuration. We'll explain the operation of SLAAC, and then we'll explain the operation of DHCP version 6. And finally, we'll configure stateful and stateless. We'll learn how to configure stateful and stateless in CP version 6 server. One thing that I need to mention is that IP version 6 is still under development, and there's still more and more that is yet to be released to the public, general public, about IP version 6. And so it's important for us to know that, just like we did get so much information yesterday for IP version 6, for IP version 4, IP version 6, not even a single packet trace activity is available for its configuration, and this is work in progress. So I know we have talked about the GUA before, which is called the Global Unicast Address, which is the equivalent of IP of a public IP version 4. It's equivalent of public IP version 4. Just like we saw that IP version 4 addresses can be configured manually, so IP version 6 devices. Okay. So it's important. Okay. So a guy here needs to. Okay. Yeah. So it's important. It's important for us to note that just like we can manually configure IPv4, we can also manually configure IPv6. And I think I've shown you this before. And now, and if you can manually configure IPv4 version 4, it's also important that we can configure IP version 6 automatically using DHCP. Now, it's important to note that because IP version 6 addresses are a bit longer in size, they are a bit about 28 bits, 128 bits. And that brings us to even the number of hexadecimal, the hexadecimals that are used are always a bit longer. And so it's a bit time consuming. And most Windows are normally enabled to acquire IP version 6 addresses automatically. And so it's important to note that the same command that we use for verifying IPv4, ipconfig or ipconfig /all is the same command that we also use to view IPv6 addresses. Now, apart from the global unicast address, the other type of IPv6 address, which we have talked about before, is called the link local address. Now, if you select automatic addressing in IPv6 within your devices, then the host will always use a protocol we have talked about before, but it's version 6, and that is the ICMP. So ICMP, which is Internet Control Message Protocol, it has for both version 4 and version 6. That of version 6 contains two messages. We call it the RA message, which we have talked about before, and the RS messages. The RA means router solicitation, and the RS means RA is router advertisement, and RS is a router solicitation. And we are going to talk about those two, very, very important. And so, like I said, a host can also acquire an address automatically within IPv6. And This happens in very different ways than we saw in IPv4. Now, you'll always see some mathematical from percentage sign, okay, and a number at the end of our link local addresses, and this is normally signifying what's called a zone ID or a scope ID, and that is always used by most operating systems to associate the link local with a specific interface. Now, the global indicus address can be dynamically or automatically assigned in 3 ways, okay? So the 3 ways are shown on the right-hand side, and the 3 ways are actually normally summarized into 2 forms. We have, it's either stateless or it is stateful. It's either stateless or it is stateful. And I wish to discuss this table here because this is all we are going to discuss today. So under dynamic addressing for IP version 6, you can either do it in a stateless manner, or you can do it in a stateful manner. And the difference between stateful and stateless is that in stateful, just like we did configure DHCP version 4 server yesterday, in stateful, there actually exists a server, and this server does something extra. This server manages the assignment of the IPv6 addresses, in that it can note what is remaining, and it can also note, what has been given out, and they get the difference. That is a stateful server. In stateless, we don't have a device that is tracking the assignment of those addresses. That is one thing I need you to note. There is no specific device. There might be a server, but that server does not do the work of tracking how many IPs have been given and how many IPs are remaining within the pool. All right. And so under stateless, we have 3 methods here. 3 methods that we have under dynamic configuration. And so we'll start with stateless, where there's no device tracking the assignment of the IPs. We will talk about SLAAC, and then we also talk about what is SLAAC with the stateless DHCP version 6 server. And at this point in time, normally I tell a story here. So listen to this. Imagine you are having you have 3 children or 3 students. We have these 3 students who go to this particular school. Okay, they might be in a high school or they're in college. These 3 students come from very different backgrounds. So we have student 1, student 2, and student 3. So the first student is a student from a poor background, right? Which means this student, of course, I'll explain. So we have a student from a poor background. We have a student from middle to do family. And then we have a student from a very rich family of background, all right? And so the thing is, this student from a poor family, when they close school, the first day he gets home, of course, all of them are actually boarders in the school. So the student from a poor family, the day he gets to school, he gets to home, he gets home from school. They have closed for the holiday, all right? The first thing he gets when he gets home is, they must have this student must have a conversation with the parent. And the kind of conversation they'll be having is, how is this student going to pay fees the next semester? How is the student going to have pocket money? And how will they buy some of their belongings? So the moment they get home, the parent tells them, very well, the parents are like, we don't have money, we don't go to work. So you are all alone. So you better go look for work for this holiday. Maybe it's a long holiday or something like that. Go look for work so that you can get your school fees. You can get to pay for, your pocket money and even your shopping, So that is a student from a poor family. the students, immediately they get home and they put off the uniform, the first thing they do is to look for work. Okay? And they look for work all over. It doesn't matter which work that they're looking for, because they have to survive, they have to stay, and they have to live, and they have to, acquire an education. Then the second student, who is from middle to do family, this student, when they get home, the parents will tell them, you know what, um, you have just closed, but we need to start thinking about how are you going to school for the next semester. Okay? And so the parents tell this student that we are going to pay for your school fees. We shall pay for your school fees. What you can do is look for work so that you can get money for your pocket money and for your shopping and any other thing that you like to buy. All right? And so here it's kind of 50-50. Okay, the parents pay the fees, and the students, need to get money for the remaining things. That is the second student. And the third student is from a well-to-do family. This student, the moment they get home, they do not even have that conversation. Okay, the first thing they think about is, where are we going for the holidays? Where are we going for the trip? Which is the newest cloth in town? And so the first day, the student doesn't worry about how fees will be paid, how pocket money will be gotten, and how shopping will be done. That is none of their business. Okay? And for them, they just know when they go back to school, everything is going to be smooth. And that's how it works. Okay? So that is that is very, very important. Now, the student from a poor family, we give him the name SLAAC only. Okay? And because in SLAAC, when a PC needs an IP address, the PC will send a message to a router, and this is a router that has its interfaces configured with an IPv6 address. So the PC will send a message. Actually, the message is called RA, a router's advertisement message. No, actually, it's called the router solicitation message, the RS. The only job that the PC need to do is to send an RS message to the router, a router that's already configured with the IPv6 addresses, and the router will respond back with an RA message. And guess what? The only thing that the PC is waiting for is to get an RA message. That RA message is everything, is all that the PC needs. It is like gold to the PC. It just needs to get an RA message, because during SLAAC, there's no server. Okay? The PC entirely depends on the RA message to be able to get everything that it needs, from the DNS, to the subnet mask, to the IPv6 address, to the domain name, and everything. So the RA message is used to fulfill every single thing that the PC needs. So you realize here, PC is all by itself. If it can't send an RS message, the RS message is being sent, those ones are the job applications. And the RA message they get are the wages you get after working. Okay? And that's why we call it SLAAC, Stateless Address Auto Configuration. So here, the PC just needs to send an RS message. And if you can ever get an RA message, that's it. That's it for SLAAC. Then we go to the second family, student, who gets some things from the parents and the rest from himself. And so what happens, the second one is called SLAAC with DHCPv6 server, which is actually stateless DHCP version 6 server. And you can see here there's a combination of SLAAC, which means the PC is going to send a message to the router, the RS message to the router. The PC is going to get an RA message from the router. Okay? It will send an RS message to the router and get back an RA message from the router. And when the PC gets this RA message, this RA does not provide everything that it needs. You get what I'm saying? It does not, it only provides some of the things it needs. But there will be a notice on the array message telling the PC that, kindly get more information from a stateless DHCP version 6 server. I'll only give you a few, okay? The rest of any additional information, contact a stateless DHCP version 6 server. And that's going to happen, okay? And the PC will contact a stateless DHCP server. And like I said, this server does not track which addresses have been given out or which ones are remaining, okay? That's very, very important to note. So, that is SLAAC with a stateless DHCP version 6 server, okay? Then we go to the student from a rich family who does not have to worry about everything. So in DHCP version 6 server, which is stateful, the PC still sends an RS message to the router, but the router responds with an RA message, and the RA message tells the PC that, you know what, you contact a stateful DHCP version 6 server, and you'll get everything that you need, okay? Acquire all your IPv6 addressing information from a router. The only thing that can be and always comes from the array message is always the default gateway, because in most cases the default gateway can be like the link local address, okay, the FE8 or something. And so it is important to note that these are three types of ways that IPv6 host devices can acquire addresses automatically. Now, let me mention one thing. I want to connect yesterday and today. Yesterday, our PCs, initially, before we completed configuring the DHCP server, the PCs also acquired an address automatically without a DHCP server. And that address was called APIPA, Automatic Private IP Addressing. That address was called APIPA, Automatic Private IP Addressing. And the APIPA, listen to this. The APIPA was starting with 169.254, whatever it is. And we said that that address cannot be used to connect to the internet. So in IP version 4, a device can also acquire an address automatically without a DHCP server, but it can never use it to connect to the internet. But in IPv6, a device can actually acquire an address without the DHCP server, but that address will be public. It can be used to connect to the internet. And that is a major difference that I wanted you guys to note there, okay? So again, as a comparison, the last method, which is the stateful one, it is the method that is the equivalent of what we did yesterday, okay? This stateful DHCP version 6 server, it is the equivalent of the DHCP version 4 server that we learned about yesterday. So get to know that one there. Now, so we are going to, of course, learn about now the nitty-gritties. We have now those details that we need to talk about here. Otherwise, by discussing that table, we actually have finished 70% of this class. So the 30% remaining are now the details, and the devil is in the details. You guys know that. Now, how a client obtains an IPv6 GUA address, the global unicast address, it depends on the settings in an array message. And like I told you, the array message is everything for a client device. And so there exist three flags in an array message, okay, which are very significant. We have the A flag, we have the O flag, and we have the M flag. The A flag means autoconfig, and the A flag is always for SLAAC, all right? A flag is always for SLAAC. And the A flag can be equal to 0 or 1, okay? If it's equal to 1, it means SLAAC is being used. If it's equal to 0, SLAAC is not being used, okay? Then the O flag, the O means other config. The O flag is the stateless DHCP version 6 server. When you see O is equal to 0, then the stateless server is not being used. When O is equal to 1, then it means it is being used. Then the M flag, the M means managed address configuration. And this is the method for the stateful DHCP version 6 server. And so I want you to look at it this way. When SLAAC only is being used, A will be equal to 1, O will be equal to 0, and M will also be equal to 0. Okay? When SLAAC only is being used, A will be equal to 0, O will be equal to 1, and M will be equal to 1. Sorry, A will be equal to 1, and both O and M will be equal to 0. When SLAAC with stateless DHCP version 6 server, then both A and O will be equal to 1. So A is equal to 1, O is equal to 1, but M is equal to 0. And then when you're using stateful DHCP version 6 server, then that is when both A and O are off. They're equal to 0, and the M is equal to 1. It is on. So I want you to get, so the formula is either 100 or 110 or 001. It means A only SLAAC, A and O equal to 1, SLAAC with stateless DHCP version 6 server, or M is equal to 1 and A and O equal to 0, both of them. That is now stateful DHCP version 6 server. So 100, 110, 110, and 001. I hope you guys are able to get that. Okay. So we have talked so much about SLAAC, and it's important to note, guys, that not every network normally has access to DHCP version 6 server. In IP version 4, obviously you need a DHCP server, but DHCP servers can be expensive sometimes. So not every network can have access to a DHCP version 6 server. But remember, every device needs to access the internet, and so it needs an IP version 6 address. Actually, it needs a public IP, which is called the GUA, the Global Unicast Address. Now, IP version 6 has given us the flexibility, okay, through SLAAC, that enables host devices to create their own unique IPv6. Listen to that. Host devices can create their own unique IPv6 global unicast addresses without the need of any DHCP version 6 server. Okay. Now, SLAAC is actually a stateless device, a stateless service, which means that there's no server that maintains networking address information. Okay. Okay. So, that is the meaning of the word stateless. Now, SLAAC normally sends periodic array messages. Okay, SLAAC sends periodic IP version 6 array messages every 200 seconds. Okay, but the PC can also request an array message from the router. But by default, the SLAAC router or a router configured with IPv6 addresses sends array messages every 200 seconds. Okay. Now, it's also important, to note, like I already mentioned, that SLAAC needs to be enabled on a device. And to enable SLAAC, you just need to enable IPv6 routing on a device. And the command for enabling IP version 6 routing is very important. You just need to say IPv6 unicast-routing on a router at the global configuration mode. IP version 6 unicast-routing. Once you do that, then your router will be able to acquire, of course, the link local addresses and the global and even the multicast addresses. That is very, very important for you to know, to enable SLAAC. Now, it's also important to note that some of these commands, some of these show commands, like the show IPv6 interface G01 and you want to filter it to only reveal the section for joined. Okay, of course that is going to give you the FF02. These are our multicast addresses. Remember, IPv6 does not have broadcast addresses. Very, very important to note. IPv6 does not have multicast broadcast addresses, but it does have multicast which begins with FF. Begins with FF. So like I mentioned, when the SLAAC only method is being used, the A will be equal to 1, but O will be equal to 0 and M will be equal to 0. That's a repetition there. When only, of course, this is talking about the array messages being sent up every 200 seconds, or when it's requested by a host. And I mean, not so much. Again, we have repeated most of the things that you can see here. But I need to mention one more thing, just one thing. And I think this is something I've talked about before, that a PC, okay, requests for an IPv6 address by sending an RA message, and it gets an RS message. Now, normally, when it gets the RA message, you know that an IPv6 address is 128 bits. It's 128 bits, all right? And so if it's 128 bits, normally what the PC gets from the array message is the first 64 bits of that address, okay? The first 64 bits. And PC needs to create the remaining 64 bits to create the whole address, okay? And so that information that the PC needs to generate the 64-bit, it uses two methods, which I think I have demonstrated before. It uses the randomly generated method, and it uses the EUI64 process, a randomly generated generation method where the PC just automatically generates the 64 bits randomly from nowhere, and he puts it together with the other 64 bits from the PC, from the router, and it forms a whole 128 bit. And this is very commonly used in Windows 10 host devices. If the PC does not obtain it randomly, it does what's called the EUI, the Extended Unique Identifier 64, the EUI64 process, whereby the PC takes the 48-bit MAC address and inserts a common figure. The PC will insert, and I think we have demonstrated this before. PC inserts the FFFE constant value in the middle of the MAC address, and the PC gets the 7th bit on the MAC address, the 7th bit on the MAC address, and it will flip it. If it's a 1, changes to 0, and if it's a 0, changes to 1, okay? And it becomes a 64-bit, and it can now be joined or, attached to the other 64-bit from the array message, and that will be it. Now, Windows, Linux, and the Mac operating systems allow normally for a user to modify this generation of the interface ID to be either randomly generated or using the EUI64 process. However, the EUI64 process has proved to be insecure at some point because someone can reverse things and be able to know what your MAC address is, and that is not a very good one in security, okay? Now, because those addresses are always generated automatically, it is very possible, because there's no server managing the allocation, it is very possible sometimes for two devices to acquire this or to create for themselves the same IPv6 address. And so what the PCs will always do is to do what is called duplicate address detection. Duplicate address detection. And duplicate address detection is when the host sends what is called a neighbor solicitation message. It's going to be sent to all the nodes in the network, or all the devices in the network. And what it's actually doing is to check if there's any device whatsoever that has the same address. Any device that is having the same address, it will respond with a message. Like when you send a ping and you get a reply, it means that device is active on the network. But here they don't send a ping, they send a message called the NS message, the neighbor solicitation message, which is going to go as a broadcast. Actually, it goes like an echo request. And when it comes back, we get a message called neighbor advertisement, the NS message, NA message. Then we know that the address is actually being used by someone. But if you don't get a message, the NA message back, they know your address is very unique and you should continue using them. That is very, very important. So they do what is called a duplicate address detection to check if there's any device that is currently using that randomly generated ID. All right. Now, we are going to repeat a few things here, and this is basically, yesterday we were able to talk about the 4 messages exchanged between an end device and a DHCP server when a device is just powered on. And we gave it the name DORA, DHCP discover, DHCP offer, DHCP request, and DHCP acknowledge. All right. Now in IPv6, we have similar messages, but with different names. Okay. And so what's going to happen is that a host will send an RS message so that it can get an array message from the router. Thereafter, the 4 messages will proceed. So the first message yesterday was called DHCP discover. In IPv6, it is called solicit. All right. Then we saw DHCP offer. In IPv6, it's called advertise. Okay. Then we also saw DHCP request. In DHCPv6, we call it request or information request. And then finally, the last one was DHCP acknowledgement. Okay. And that in IPv6, we call it reply. And so it's important that we do note some of this, about IP version 6. Now, in terms of the stateless operation, like I said, in a stateless DHCP version 6 server, both the O flag for auto configuration for SLAAC, and that is A flag for auto configuration for SLAAC, and the O flag for other config information must be set to 1, and then the M flag, of course, is set to 0. Okay, and that is for for stateless DHCP operation. For to enable stateless DHCP on an interface, it's important that we note this. And we, as a country and as the whole world, of course, we have run out of IP version 4 addresses, and now all of us need to have some comfort and some confidence with IPv6, and that's why we are teaching some of these things. And so to enable stateless configuration, we need to say IPv6 ND. ND means neighbor discovery. IPv6 neighbor discovery, that's a command, by the way. IPv6 ND other -config -flag. So IPv6 ND other -config -flag, and that is how we enable the stateless server within the router. Very, very important. Okay, and so that is going to set the both the A and the O flags set to 1. Okay, and you can always remove it by using the no form of that command. Just put a no saying no IPv6 ND other -flag. Okay. Now, for a stateful DHCP operation, like I told you, this is the equivalent of the IPv4 DHCP. Okay. And so the PC receives an array message, and the array message will, of course, contain the IPv6 global unicast and network prefix and the prefix length. And so a flag of 0, the A flag must be set to 0. Okay, informs the host that they need to contact a DHCP server. And the O flag is also set to 0. So both the A and the O flags set to 0, informing the host device to actually check with the DHCP server, stateful DHCP server. And at this point, the M flag is always set to 1. Okay. And so piece 1 send a DHCP solicit message, like a DHCP solicit message seeking for any additional information from a stateful DHCP server. So at this point, this is the only point when M is equal to 1. Both O and A and O must be equal to 0. How do you enable stateful DHCP server? Very simple. You get into the interface facing the client and you just say IPv6 ND. ND means neighbor discovery. IPv6 ND managed-config-flag. Managed-config-flag. That is setting the M flag to 1. And of course, at this point, both the O flag and the A flag are, of course, set to 0. Let's look at some few elements of configuration here. The chapter still lacks packet trace activities for configuring IPv6, but probably in later days they will be providing that because we are shifting very fast to IP version 6. Now, so Cisco devices do have some iOS commands that can be used to configure. And one thing to note, borrowing from yesterday, is that yesterday we were able to configure Cisco router to be, number 1, a DHCP server, 2, to be a DHCP client, as it was able to receive an address from a DHCP server, and 3, it became a relay agent. The same thing is possible in IPv6. You can set a router to become a DHCPv6 router, client, and a DHCPv6 relay agent. So it's important that we note how is it that some of these things are done and what are the variations. And we are going to check on them one by one. So let's start by how to configure a stateless DHCPv6 server. Stateless DHCPv6 server. So the first thing you need to do, like I had already mentioned, is you need to enable IPv6 routing on your router. And so you say IPv6 unicast-routing. That is used to enable IPv6. Remember, our routers are not originally designed for IPv6, but by default they are always enabled for IPv4. So to use IPv6 in them, you must say IPv6 unicast-routing. After that, just like yesterday, you need to define a pool, and you can see we say instead of saying IP DHCP pool, and then you put the name, you say IPv6 DHCP pool. So we're just changing the word IP to IPv6. So that's used to create the pool. Remember, we are still in a stateless DHCP server. Once you create the pool, you need to configure the different options of the pool. This can be things like DNS server, put the IP address of the DNS server, domain name, and so on. And because this is stateless, this is the point you need to say IPv6 ND other-config-flag. IPv6 ND other-config-flag. You're going to set the O flag to 1. And then from there, you can now verify your host devices using the IP config/all if they are receiving any IPv6 addresses. That is very, very important, again, for us to know. So that's a stateless DHCPv6 server. Enable IPv6, create the pool, configure the pool options, and then you, by the way, need to bind the pool to the interface. The interface you're setting for SLAAC, that's a very important point I forgot there. You must bind the interface to that particular pool. And the command is IPv6 DHCP server, IPv6 DHCP server, and then you put the name of the pool. And this is done on the interface. IPv6 DHCP server, and you put the name of the pool. Okay. Now, for us to make a router a stateless DHCPv6 client, just like we did yesterday, you want to make the router to acquire an address like a client. So the first thing that router needs to do is that you must enable IPv6 routing by saying IPv6 unicast hyphen routing. They need to configure the client router to create a link local address. Configure the client router to create a link local address. Now, it's important to note that every time you configure a router interface, with an IPv6 address, the interface will automatically create a link local address. Okay, every time you configure a router interface with a global unicast address, then it will automatically create a link local address. But if you don't create a link local address, you can also do another thing. You can also use the command IPv6 enable on the interface, and it will use the EUI64 process in order to create that interface ID. So that is very, very important. Okay. So it can still be able to acquire a link local address, and that is important. So do note that. So after enabling IPv6 routing using IPv6 unicast hyphen routing, then configuring the client router to create its own link local address. And the third thing, you need to configure the client router to use SLAAC. Configure the client router to use SLAAC. And on the router, you're going to put this command, IPv6 address autoconfig. You do that. Remember yesterday on the interface, we said what? For the router to become a client, we said IP address DHCP, and the interface, we activated the interface, and it was able to acquire an address automatically. So for IPv6, you go to the same interface that you need to acquire an address, and you say IPv6 address autoconfig. Very important. Then if you can verify the client router using the show IPv6 interface brief, show IPv6 interface brief, it will actually, you'll find an address there. Okay. You can also, verify the client router that has received the necessary IPv6 information by using the command show IPv6 DHCP interface G001, for example. Show IPv6 DHCP interface G001 command, and that is going to confirm the DHCP option information like DNS server, domain names, and all that have been received. So that is making a router to become a stateless client. Stateless client. What if you want to make a router to become stateful server? Stateful server. But then clientless, there's no really agent thing. It's important to note that. So now we talk about stateful DHCP server. This is like the equivalent of the IPv4 DHCP version 4 server we did talk about yesterday. So the same thing, enable routing, enable IPv6 routing by saying IPv6 unicast hyphen routing. All right. Then you need to define the DHCP pool name. Define the DHCP pool name. Define the DHCP pool name by creating the pool. Instead of saying IP DHCP pool and put the name, you say IPv6 DHCP pool. IPv6 DHCP pool, then you put the name. Then thereafter, you need to configure the pool with some options, including the network address. Here we call it the addressing prefix, the domain names, okay, the DNS server IP addresses, the subnet mask, and so on and so forth. So you populate now, you'll be able to configure the pool with options. Then as usual, you must bind the pool to an interface. And you say IPv6 DHCP server, IPv6 DHCP server, and you put the name of the pool. And you configure this on the interface. IPv6 DHCP server, and then you put the name of the pool exactly as it is. Okay. Now, because this is stateful, the M flag must be changed to 1. And you say IPv6 ND managed -config-flag. You change the M flag to 1. And then you must now manually change the A flag from 0 to 1. And you say IPv6 ND prefix default no autoconfig. Very, very, very long commands here for IPv6. IPv6 ND. ND means never discovery. Prefix default no autoconfig. No autoconfig. You do this on the interface, and this is going to inform the client not to use SLAAC in any way to create its global unicast address. But the router is going to respond to stateful DHCP request with the information that you have already configured within the pool. And you can now check with your PCs, check with your laptops using the ipconfig/all on their command prompts to see if they are able to acquire this IPv6 information. All right. Now, it's important to note that you can also configure a router to become a DHCP client. All right. How can a router receive an address automatically? And so obviously the first thing is you need to enable IPv6 routing by saying IPv6 unicast hyphen routing, IPv6 unicast hyphen routing. Now, once you enable routing, you need to configure the router to create its own link local address. Okay, configure a router to create its own link local address, and it can create its own link local address if the router connected to it, there's another router which is already configured with an IPv6 address, and so it can actually acquire a link local from it. Or you can use the command IPv6 enable, okay? And this is a command put on the interface. Now, then you need to configure the router to use DHCP, and this is very similar to what we did yesterday. Yesterday we said IP address DHCP and the router, and we activated the interface, and it was able to acquire an address. The only thing that changes here, replace IP with IPv6, replace IP with IPv6. So here you say IPv6 address DHCP. You are supposed to replace IP with IPv6. So you say IPv6 address DHCP, IPv6 address DHCP. If you say show IPv6 interface brief for IPv6, that command is going to display that the interface has received an address via DHCP version 6. Okay. Or you can still check the client router by using the command for the DHCP version 6 information. Use the command show IPv6 DHCP interface G001 if that is your interest or interface of interest. Okay. And so we have seen router as a server, DHCP version 6 server. We've seen router as a stateful DHCP version 6 client. And this keeps on repeating. The last thing is now, how can we make a router to become a relay agent? Of course, this is the show IPv6 DHCP pool, and you can be able to see a few things here. You can be able to see that the name of the pool here is IPv6-stateful. That's the name. We prefer the name in capital letters, but it's not a must, but it stands out. Okay. Then the network address is actually here, 2001. We call it the prefix, DB8:1:1:/64. The validity time, of course, it's here. How many addresses are currently in use? 2 are currently in use. DNS server address is here. Domain name is here. Of course, there are 2 active clients, right? Now, it is important that we know how that the command we used yesterday, the command for show IP DHCP binding, whereby you look which MAC address has been bound to which IP address. That is the same thing in IP version 6. Remember, every address, especially in stateful, every address that is assigned to a client device, it must be recorded within the router, and it must be attached to the MAC address of the PC to which it was given, the MAC address of the PC that receives that particular address. And so that is one thing that you guys need to note. Okay, so show IPv6 DHCP binding. Show IPv6 DHCP binding. You can see here that there's a MAC address that has been bound here, all right? And the specific address that it was assigned is actually here, 2001:8 card, all that here. And there's what time it was given, the validity period is here in seconds normally, and even the expiry time is actually here, all right? Very important. And there's another client here, the second client is here, and the IPv6 address it was assigned is here, and the preferred lifetime is actually here in time, and the expiry day is September 27, 2019 at 9:29. You know. So this is not very far from IPv4, you know, just a few differences here and there, few differences here and there. The last thing that we see in IP version 6, the last thing that we normally see in IPv6, and we also talked about it yesterday, is the relay agent. The relay agent. Remember what we talked about the relay agent yesterday? We did say that this IP version 6, okay? The IP version 6, no, yesterday we talked about IPv4. You say that IP version 4, wherever the server is on a different network than the client or from the client. This is the DHCP, stateful DHCP server, and this is the client device. And they are on two different networks, and they are separated by this router R2. And so for the DHCP messages to move from server to client and client back to the server, we need to configure the router in the middle here as a relay agent. And if you still remember what I said about the relay agent must be configured on the interface facing the client. And yesterday we were using the command IP helper -address, the helper address. And today the command has changed in IPv6. All right. So, but the basics have remained the same. The address must be configured on the interface facing the client, but you must put the IP or IPv6 address of the server. So let's look at this. So the first thing to note is that we must configure it on G001, and you can see interface gigabit Ethernet 0/0/1. All right. Then the command, instead of saying IP helper -address, you say IPv6 DHCP relay destination. IPv6 DHCP relay destination. Once you say that, then you must put the IP address of this interface. This is the interface of the server connecting to the relay agent. Let me show you how to identify that IPv6 address. This is the interface G000 right here. We know very well that this network between R1 and R3, the network address is here, which is 2001:ACAD:1:/64. And we know very well from our previous lessons that where the double colon is, you just need to replace it with the :2 here to tell you what is the IPv6 address of this interface. And for that of this interface, for G00, you just need to, where the double colon is, you put :1. This other one, you put :2/64. And so that is the address that is here, 2001:DB8:ACAD:1:2. That is the 2 we see here. Then you must also put what is called the exit interface. So we must put this address, you know, I don't know whether I have ever told you guys, but we are going to talk about it towards the end of this course. We have what is called the next hop IP and the exit interface. So you start by the next hop IP, which is when you're in this router R1, that IP is actually for this router. Then this interface here is actually the interface. We call this the exit interface. When you leave R1 going to R3, you must leave through this interface, G00. But when you leave R1 going through R3, you must enter through an interface to get to R3. That interface is G0/0/0. It's actually what we put here, and you are good to go. You can activate this interface by saying no shutdown, and that's it. That device will now act as a relay agent, and it will be transmitting the DHCP messages from the server to the client back to the server. Yeah, and I think this is really much that I wanted us to talk about today. Yeah, the rest we will be able to, talk about tomorrow. The rest are just show command, like show IPv6 DHCP interface, or uh, show IPv6 DHCP binding. The same thing that we just talked about. And on your PC's ipconfig space/all. Yeah, and that's all IPv6. So IPv6 is still developing. There's still more and more research being done on IPv6, and currently Cisco hasn't provided so much practice for IP version 6, and that is something very, very unfortunate. But I mean, I think in the near future, because the transition is inevitable and we cannot run away from it, there's going to come a time when we are going to have, to know how to configure even stuff within IP version 6. Okay.